Hi, Bill Barber from Poliigon here. In this video we're going to look at how to properly make use of a polygon displacement texture in Blender. Before we get started though, let's take a look at the material that we'll be using. It's this one, Ground Asphalt Broken 001, and it's definitely one of my favourite materials here at Poliigon. Really nicely displaced ground material, which is ideal for demonstrating this. So yeah, I have that saved and available for use, and I'll link it below the video. Okay, let's head over to Blender. Okay, so this is the scene that we'll be working on today. It's again a very simple scene, just a plane and a camera, and that is about it. I've already set up some lighting. In fact, let's jump over to shading now, and we'll be able to take a look at that. There we go. So we've got this kind of relatively moody sort of lighting, which fits the material quite nicely, I think. And what I am going to do is hit Control B and just use the camera for rendering rather than the border around it. Good. So with the plane selected, I'm going to go to the Material tab. We've got our Material Converter already set up and good to go. I'm just going to deselect everything, and then we need to load up our texture, which, as we said a moment ago, was Ground Asphalt Broken. You can see the material preview of it there, so we've got the right one. And then I'll just hit Load Material, and then Apply. And that will apply our material to our ground plane. And there we go. So, yeah. Initially the result is not looking particularly awesome, and it wouldn't by default because we haven't got any displacement set up. But before we get started on that, I do want to make a slight adjustment in that I want the scaling to be a little different. So let's try a value of about 2.5. Yeah, I think that'll work quite nicely for us. Now, in a previous video, I mentioned that by default our material converter brings in the displacement map and kind of adds the information from it via a bump node, which is a very efficient way of doing it if your material doesn't require displacement, but we do in this example. So let's highlight the bump node and just press Control and X, and that will delete the node without deleting the connection. The normal map is still connected there, and that's left our displacement map free to be used elsewhere. Good. So I'm just going to move these nodes up a bit and get them out of the way. And then let's open up the displacement map. Good. So in Blender 2.8, there's a slight change to the way displacement is handled. There's a new node called displacement. So let's add that in to start off with. Shift A, and then texture, no, vector, sorry, displacement. And then we have our new displacement node. That would be going into the height value. So that's where I'll feed that into. And then what we'll do is feed the displacement node into the displacement input of the material up there. Good. So in terms of the node setup, we're done. We're good to go. So why isn't our material looking great? Well, the reason being, if I jump over to shaded mode for a second, I'll tab into edit mode, and that will show all the geometry of our material as it is at the moment. And as you can see, it's not massively dense, so all the displacement has to work with at the moment are these vertices. So what we need to do is give it more to play with. Now we're going to use, I'm going to show you two methods. First of all is the traditional subdivision, so let's do that first. Add in a subdivision surface modifier, and then what we'll do is just crank that all the way to 6, so we're getting loads and loads of subdivision within our mesh. Jump back over to rendered mode. It will take a little while because there's more geometry for it to think about and calculate, and then what I'll do is up the strength of this displacement to say 10. And that still isn't giving us much of a result, or any, I should say. And there's a good reason for that. You have to enable displacement within the material itself for it to work. So let's jump over to the material, scroll down to settings. Here we go. And you've got this little part called displacement method. Change that from bump only, which is the default, to displacement and bump. Give it a minute to recalculate. And we can see our displacement working. I perhaps went a little bit high with the value of 10, so let's try a 2. Yeah, and that is starting to look really nice. I'd probably turn that down just a little bit more, maybe 1.75 or so. But yeah, that looks good. Now, the problem we have is I'm using 6 levels of subdivision, which is creating a huge amount of geometry, which is good for these closer to the camera parts, but we're getting the same amount of geometry right at the back here where we can't see the detail as much, and that's not really ideal. So another route we can go down with Blender is to use adaptive subdivision. Now the good news is that the material settings now work for both methods, so we're not going to have to change our node setup here, just change the modifiers a little bit. So let's just jump out of rendered mode, because sometimes it can be a little unstable, and change the feature set from supported to experimental. Now when we jump over to our modifier stack, you'll notice that the subdivision modifier is still there, but it's changed slightly. We've got this option for adaptive now. So what I'll do is turn the views down to 1 to keep our viewport nice and efficient, and then I'm going to turn on adaptive, and that will give us this dicing scale. Now the way adaptive subdivision works is it takes the camera, the point of view at the start of the render, and adaptively subdivides from that point. So it will give you lots of geometry close to the camera, and then as the distance increases it will scale off that geometry until it's not giving you any subdivision whatsoever, which is a way more efficient way of doing subdivision. So let's up this dicing scale, because basically the lower the dicing scale, the higher the subdivision. And we don't want to go crazy, because typically on a value of 1, if you don't have a lot of system resources, you could actually crash your machine just trying to run that. So we'll start off safe at about a value of 3, and then rather than jump into rendered mode, I'm actually just going to hit render, just because I've had some stability issues with this current build of Blender, and we'll see what we get. And there we go. Looking pretty good, actually. The value of 3 was actually probably still a bit too severe. You can see from the memory usage here, I'm using up nearly, or just over 3 gig of memory just to render out this one element. If you were doing an entire scene, that would be a big chunk of your memory gone. So we could probably get away with a higher dicing rate and a little less subdivision. But yeah, for the purpose of a tutorial, I think that works well. So in summary, we've downloaded a Poliigon material, brought it into Blender, and explored how to properly make use of the displacement texture, both with traditional subdivision and adaptive.